Hi, hey everybody, and welcome back. We are on the Chapter 8 test study guide, so I'm going to do a walkthrough and work through these problems with you guys, and if you have any questions, hopefully this answers them for you and shows you how to work anything you may have forgotten about. So let's go ahead and get started. All right, the first part says, given one form of a quadratic equation, write the equation in the requested form. So we're just switching forms. So the first thing that we need to do when we look at A, we've got negative 3x squared. That x squared tells us that this is in standard form. Okay? And then it wants us to present it in factored form. So we're going to factor this out. The first thing we need to do is pull out our greatest common factor. So we notice that 3 is the greatest common factor among these numbers, but also don't forget, if you lead with the negative, it is part of your GCF. All right, so we're going to not just pull out 3, but negative 3. Okay? And then whatever we multiply that by to get this number back up at the top. So it would be x squared, 5x. Don't forget you have to switch your sign when you pull that negative as a greatest common factor. You have to switch that sign so that you make sure you get back to the original negative 15. And then also positive 4. Okay, and now we can factor out this just like normal. Okay, a times c goes at the top, which would just be 4. B goes at the bottom, which is 5. And ax would be 1x on each side. Okay, so this one's actually a pretty easy one to factor out. What can we multiply to 4 and add to 5? Well, it's just 4 and 1. All right, 1 and 4 can't be simplified. Obviously, neither can 1 and 1. So we're going to factor that back out over here. Don't forget to pull your greatest common factor, which was negative 3, times x plus 4 times x plus 1. All right, so it asks for our x-intercepts, y-intercepts, and vertex. Remember, with the zero product property, we can set our factors equal to 0 and solve for that x. So as long as there's an x in there, we want to set it to 0. So x plus 4 equals 0, and x plus 1 equals 0. Right, so if we have plus 4, we're going to subtract it, so we're going to be left with x equals negative 4. And if we have plus 1, we're going to subtract that as well and get x equals negative 1. Okay, and then notice it asks for our x-intercepts, not zeros, roots, or solutions. So we write these as ordered pairs. Negative 4, 0, and negative 1, 0. Remember, x-intercepts has a terrible arrow. Remember that x-intercepts have a y value of 0. All right, now we have our y-intercept. So remember, hopefully in our standard form, c is our value for our y-intercept. So that would be 0, negative 12. Remember that y-intercepts have an x value of 0. All right, and then we need to figure out our vertex. So let's pop over to our calculator real quick. And we're just going to plug this in. So we have, and you could do it in the standard form or the factored form, you'd get the same answer. The calculator does not care what form it's in, but we're going to go with standard. So negative 3x squared minus 15x minus 12. All right, let's graph it and look at it. I'm zoomed in, so I'm going to go back to zoom standard. All right, so we notice that we have a maximum, so second graph, nope, not graph, second trace, maximum. Go to the left side of your vertex, anywhere beyond the vertex on the left side, and then anywhere beyond the vertex on the right side as well. Hit enter one more time, and we get negative 2.5 and 6.75. So we're going to round to the nearest hundredth like the directions asked, so we're going to say negative 2.50. So our vertex will be negative 2.50 and 6.75. All right, we're going to do the same thing with B. So once again, we were given that x squared plus x, so that is our standard form. All right, and it wants us to give it back in factored form. So between 12, 2, and negative 70, obviously our greatest common factor can't be higher than 2. And 12 and 70 are both divisible by 2, so that's what we'll pull out as our greatest common factor. So 2 times 6x squared would give us 12x squared. 2 times x would give us 2x. And 2 times negative 35 will give us negative 70. So now we're going to factor this trinomial out, just like normal. All right, so a times c goes at the top, 6 times negative 35. It's going to be negative 210. And then b goes in the bottom. Remember, if it's just x, that is understood 1, okay? And then ax on the side, so 6x on both sides. All right, I want to remind you guys how to find factors that you're not sure about. And negative 210 and 1 is one of those that you may not just know right off the top of your head. So let's go back to our calculator, and I'm going to show you guys how to find factors with your calculator. So take this value at the top, which is negative 210, divided by x for y sub 1. And then for y sub 2, you do negative 210, also divided by x, but then you do plus x. And you want to look at your table. So second graph, and you've got your table here, and we want to find our b value, which is 1 in this y sub 2 category. So notice we've got 1 right here. So that means our two factors are negative 14 and 15. That looks like 19, but it is 4. All right, so 6x over negative 14 can be simplified by 2. These are both divisible by 2. So this simplifies to 3x over 7, negative 7. Remember that you need to keep your negatives where they are, and also you always need two numbers. You don't just simplify to 1 if it is divisible. So 6x over 15 also simplifies, and this would be 2x over 5. Okay, those are both divisible by 3. So our factored form would be y equals your GCF of 2 times 3x minus 7 times 2x plus 5. All right, for our x-intercepts, we're going to set these factors to 0. So we have 3x minus 7 equals 0, and 2x plus 5 equals 0. All right, we're going to add 7 starting off to solve for x. So that would give us 3x equals 7. Then we're going to divide by 3. This x is being multiplied by 3. So remember your very simple equation rules from like chapter 1. So if we're multiplying by 3, to get rid of it, we'll divide. So x will equal 7 over 3. That cannot be simplified. Same thing over here. First, we want to get rid of this plus 5, and we're going to do that by subtracting. So we get 2x equals negative 5. And then we're going to divide by 2. So x equals negative 5 over 2. All right, so once again, it asks for the x-intercepts, not for the solutions, roots, or anything like that. So we're going to write those back as ordered pairs. So our first ordered pair would be 7/3 and 0. And our second would be negative 5 over 2 and 0. Be really careful you're watching what it's asking you for an x-intercept or a 0 or a root. Those are going to be written differently, okay? So our y-intercept, that c value of our standard form. So we would have 0, negative 70. All right, and then let's go back to our calculator and figure out our vertex. We're going to go to y equals and clear this out. Once again, either form will work. So 12x squared plus 2x minus 70. I just noticed these signs are totally off. Okay, so 12x squared plus 2x minus 70. And then y sub 2, don't forget your 0. So we're going to graph this. I'm going to go ahead and zoom out. Oh, that's not what I meant to do. Let's do zoom fit, see if that fits on there better. There we go. So we know we have a minimum. So second trace, minimum. We're going to go to the left side. When you're on that zoom fit, sometimes it's hard to tell. So make sure you see your cursor. And then right bound. enter, and enter one more time. So we have negative 0.083332. We're going to round that up. And then we have negative 70.08333. We're going to round that as well. So our vertex would be negative 0.08. Remember, we're going to round to the nearest hundredth. Oh, didn't mean to close that. And negative 70.08. All right. We've got one more of these. Notice now we have this parentheses, parentheses. So this tells us we're starting out in factored form. So it wants us to put it back in standard form. So the first thing we need to do is distribute this out. And we're going to do this with the FOIL method. Remember, FOIL is first, outer, inner, last. So just ignore your 6 for a minute. Just keep it to the side where it's at. So 5x times 3x gives us 15x squared. 5x and negative 4 gives us negative 20x. Negative 2 and 3x gives us negative 6x. And negative 2 and negative 4 gives us positive 8. All right, we've got some like terms we can combine. So 15x squared minus 26x plus 8. And now we can distribute the 6 out. So 6 times 15, it's going to be 90x squared. 6 times negative 26x, negative 156x. And 6 times 8 would be plus 48. So we'll write that back in standard form. Y equals. All right. So it wants us to find our x-intercepts. Remember, we can take these factors, set them both equal to 0, and solve for the x. So that's what we're going to do. All right, so we're going to start first by getting rid of this 2, by adding it to both sides. So we have 5x equals 2. And then we're going to divide by 5 to get x by itself. All right, same thing over here. Add that 4 and get rid of it first. So we have 3x equals positive 4. And then divide by 3, so we get x equals 4 over 3. So our x-intercepts, once again, ordered pairs. All right, our y-intercept we can pull from the standard form that we found, that c value. All right, now we're going to go back to find our vertex. So we're going to go back to our calculator. We're going to plug this in. Let's graph it. I'm going to do zoom fit. So we have a minimum, so second trace minimum. Go to the left side. Go to the right side. And hit enter one more time. So we get 0.8666566. We're going to round that, and negative 19.6. All right, number 2 tells us to find solutions to the following equations. So notice first we have 3x squared equals 12. Well, the first thing that we're going to do, we're trying to solve for x is what we're doing. So the first thing that we're going to do is get rid of this 3 by dividing. So we have x squared equals 4, and we want this x to be alone, so we need to get rid of this squared, and we're going to do so by taking the square root. So remember, what you do to one side, you have to do to the other. So we get x equals, remember, a square root is going to be a plus or a minus 2. All right, for b, remember with the trinomial, we can take the square root of a and the square root of c and square that, right? So take the square root of x squared, square root of 25. So we're going to have x plus 5 squared, and we set that equal to 0. All right, so now that we've done that, we want to get rid of this squared exponent as well. So we're going to take the square root of both sides. So the square root of x plus 5 squared is going to leave us with x plus 5, and the square root of 0 is 0. So now we can get this x by itself by subtracting 5, and we get x equals negative 5. All right, for number 3 and 4, we're going to use the zero product property to solve. So that means we need to factor this out and then find our zeros. So the first thing for 2x squared minus 10x, you may assume difference of squares, but don't forget to notice this x right here, okay? So that means we're not going to do difference of squares. We need to pull out our greatest common factor, which in this case would be 2, but we also have an x in each, so we can pull out 2x. So this would be times x to get 2x squared, and times negative 5 to give us negative 10x. Right, so now remember any factor with with an x in it is what we're going to set equal to 0. So we would have 2x equals 0 and x minus 5 equals 0. So to solve for 2x equals 0, to get this x alone, we're going to just divide by 2. So 0 divided by 2 is just going to be 0. So our first one is 0. And then to get this x alone, we're going to add 5. So we get x equals 5. All right, number 4. Notice we were already given the factors, so we don't have to do anything to factor this out. We just have to set them equal to 0. Okay, so 3x plus 2, we're going to start by subtracting that 2. So we get 3x equals negative 2. And then we divide by 3, so we get x equals negative 2/3. For x minus 14, all we have to do is add that 14 to the other side. So we get x equals positive 14. Okay? All right, let's get started on the back. So find the roots of the following functions. So finding the roots or finding what those x values of our x-intercepts are, right? So we're going to start by factoring this out. Between 11, 3, and 8, there are no greatest common factors, so we're just going to factor it out. So remember, a times c goes to the top. 8 times negative 11 gives us negative 88. And b goes to the bottom of negative 3. Right? And then 8x will go on each side. All right, so this one's actually easier than you think. So to get negative 88 when you multiply and negative 3 when you add, it's just going to be 8 and negative 11. If you need to pause and make sure you can figure out these factors on your own, practice with the calculator, make sure you get those factors. So 8 and negative 11. We always want the higher number to be negative if we need to end up with a negative 3. Okay, so the only one out of these two that can be simplified is this 8x over 8. Don't forget to simplify, it's crucial. So this will simplify. They're both obviously 8, so it would be x over 1. Right, so we get x plus 1, and we get 8x minus 11. So we're going to set those equal to 0. So x plus 1 equals 0, 8x minus 11 equals 0. Right, so to solve for x, we're just going to subtract 1, so x equals negative 1. And then for this one, we have a couple more steps. We're going to start by adding 11. So 8x equals 11. And then we're going to divide by 8. So we get x equals 11 over 8. All right. 6 and 7 say solve the following quadratic equations by factoring. So we're going to do pretty much the same thing. So between these, we have 3, 17, and negative 20. We also don't have a greatest common factor on these, so we're going to factor like normal once again. So a times c, 3 times negative 20 gives us negative 60 for the top. B goes at the bottom of 17, and then we put 3x on the sides. Okay, so what can we multiply to negative 60 and add to positive 17? So think of your factors of what you could get to negative 60, and then see which one works for 17, or type it in your calculator, whichever one works. So we get 20 and negative 3. Multiply to negative 60, add to positive 17. All right, so out of these, the only one that can be simplified is this 3x over negative 3, which is just going to be x over negative 1. Remember that you have to keep this 1, even though they're both divisible by 3. You have to keep something on the top and the bottom, and you have to keep the negative where it was supposed to be originally. So we have 3x plus 20 equals 0. And we have x minus 1 equals 0. Right, so we're going to start by subtracting 20. So we have 3x equals negative 20. And then we're going to divide by 3. That actually can't be simplified, so we're going to leave it as negative 20 over 3. Right, for x minus 1, all we've got to do is add the 1, so we get x equals 1. All right, between 8, 18, and 10, we do have a common factor, a greatest common factor, and it's 2. So 2 times 4x squared times negative 9x and times positive 5. Right, now we're going to factor out this trinomial. Alright, so a times c, 4 times 5, goes at the top, that's 20. B goes at the bottom, negative 9. And then we put ax at the top, so 4x on each side. Alright, so what can we multiply to 20 and add to negative 9? This is one where you have to be careful because we want a positive up top and a negative at the bottom. So we can multiply two negatives together to get a positive and also combine two negatives to keep that negative. So it's easier than you think, so it's negative 5 and negative 4. Okay, 4x over 5 cannot be simplified, but 4x and negative 4 can. And that would be x over negative 1. So we've got 4x minus 5 equals 0, and x minus 1 equals 0. Right, so we're going to start on this one. We're going to add 5. So we have 4x equals positive 5, and then divide by 4, and we get x equals 5 over 4. And then for this one, we're just going to add the 1, so we get x equals 1. All right, so number 8 tells us to classify the following functions as linear, quadratic, or exponential. So this is when you need to figure out if you find it with subtracting, and if you do find it with subtracting, do you find it with the first difference or the second difference, or do you find it by dividing? So when is the number the same? So we go 4, 2, 0, negative 2, 4. That's not a huge change, so let's just try subtracting. So negative 4 minus negative 2. That's negative 4 plus 2, so it leaves us with negative 2. Negative 2 minus 0 leaves us with negative 2. Looks like we're on the right track. 0 minus 2, negative 2 as well. And 2 minus 4, also negative 2. So notice that this was the first difference when we got the same number. So because it was the first difference that we subtracted, that means this is a linear function. All right, we go from negative 4 to 0.25. That's a pretty rapid jump, so let's just try dividing it. So negative 0.25 divided by negative 0.5 gives us 0.5. Negative 0.5 divided by negative 1, also 0.5, so that may be right. Let's keep going. Negative 1 divided by 2, 0.5 once again. And then negative 2 divided by negative 4, also 0.5. So we divided this, which means we have a ratio. Think back to arithmetic and geometric. So because we divided and got the same number, that means that we have an exponential function. Okay, last one. 3, negative 5, negative 9, negative 9, negative 5. Well, that one could kind of be anything, so let's just try subtracting. So negative 5 minus negative 9, that's negative 5 plus 9. That gives us 4. Negative 9 minus negative 9, that's negative 9 plus 9, so that gives us 0. So notice we don't have the same number, but it could be quadratic, meaning we find the same number on the second difference. So keep going. Negative 9 minus 5 minus negative 5 is going to give us negative 4. And then negative 5 minus 3 is going to be negative 8. Okay, so they're not the same, but let's see if we can get the same number with the second difference. So 4 minus 0, 4. 0 minus negative 4. Minus negative 4 means plus 4, so positive 4. And then negative 4 minus negative 8, that's negative 4 plus 8, so we have 4. So we got the same number on the second difference. All right, that means we have a quadratic function. All right, it says for 9 through 11, for each situation, write an exponential equation. So let's start with number 9. First thing it asks, is it growth or decay? Well, remember we read left to right, so we are increasing, so we have growth. All right, our y-intercept, it's very hard to tell. Hopefully you can see this on Schoology, on the assessment, or also on the printed version of the study guide. So our y-intercept, that is 0, 3. Very blurry on the screen, so I apologize. All right, now we need to find our multiplier, which means we need to pull these points into a table. So we know we have 0, 3. That next point is 1, 6. This third point is 2, 12. And our last one is 3, 24. All right, so let's start. Remember, to find our multiplier, we got to subtract this side. Divide this side, not subtract. So 24 divided by 12, 2. 12 divided by 6, 2. 6 divided by 3, 2. Easy enough, so our multiplier is 2. All right, we can write our equation. Y equals, remember this formula, it's been a minute since we've done it, but y equals our y-intercept of 3 times our multiplier of 2 raised to the power of x. Okay, we went from 8 to 8 over 27. So as we go on our y values, we are decreasing. That means we have decay. All right, we don't have a y-intercept with an x value of 0, so we need to go ahead and find our multiplier. So once again, let's divide. 8 over 27 divided by 8 over 9, it is 1/3. 8 over 9 divided by 8 over 3, also 1/3. And then 8 over 3 divided by 8, you guessed it, 1/3. So that means our multiplier is 1/3. And now we can find our y-intercept. So we need to find 1, and then we can find 0. So 8 divided by 1/3 is going to give us 24. And 24 divided by 1/3 is going to give us 72. So remember, we're dealing with exponential growth and decay here. So the fact that we went from 72 to 8 over 27 is totally normal and actually makes sense with an exponential. So our y-intercept is 0, 72. So we can write our equation. Y equals our multiplier, our y-intercept of 72 times our multiplier to the power of x. All right, for number 11, we were given 2 ordered pairs, and notice that these are non-consecutive. This means we have to subtract our x values. This is very, very important that you don't forget. So let's go ahead and make a table and fill out what we do know. So we have 0, 64. Make sure you put these in the correct order. And 3 and 1,728. All right, so first things first, we can tell we have growth. We went from 64 to 1,728. So we increase, that's growth. All right, and then we already were given our y-intercept with an x value of 0. So 0, 64. And then our multiplier, we have to figure out. So 1,728 divided by 64, that gives us 27. But notice up here, remember I said if it's non-consecutive, you have to subtract x. So we have to subtract over here. So 3 minus 0 gives us 3. So that means we're going to take the cube root. You would take it, if this was 2, you would take the square root. 3, you take the cube root, so on and so forth, of 27. So we're going to take the cube root of 27, which is 3. So our multiplier is 3. So our multiplier is 3. So our equation is going to be y equals our y-intercept of 64 times our multiplier of 3 to the power of x. All right, second page. All right. Number 12 says, a small independent motion picture company determines the profit P for producing N DVD copies of a recent release is this long formula function. P is the profit in thousands of dollars, and N is in thousands of units. Excuse me. So the question says, how many DVDs should the company produce to maximize the profit? Okay, so what we have to do with word problems is figure out what mathematically it's actually asking from us. So if it's asking how many they should produce to maximize the profit, Well, we know we have a maximum or a minimum on our parabola, so that maximum or minimum is our vertex. So this is really asking us, what is our vertex? So what will that maximized profit be? So what we need to remember, hopefully we remember our value to solve for x was negative b over 2a. So we can use this to solve for our vertex. So this x in this problem is actually our variable for n. So I'm going to put n in parentheses beside this. So negative times b, which was 3.4, over 2a, so 2 times negative 0.02. All right, pull up your calculator. Oops. And just plug this in like normal. Alpha y equals will give you the option to plug in a fraction. And then 2 times negative 0.02. And we get 85. So n equals 85. Right, now we're going to take that and plug it in anywhere we see an n in this. So come back over here to your calculator. So negative 0.02 times 85 squared plus 3.4 times 85. Anywhere you plug this in, by the way, you're multiplying. So put it in parentheses, minus 16. And we get 128.5. So that is our value for P, right? P equals this whole thing worked out. So we know that P equals 128.5. So that is our vertex, right? So it would be XY, 85, 128.5. So when it asks us how many DVDs should the company produce to maximize the profit, we're looking at what we solved for N. Okay, but go back to your problem. Remember, it says thousands of dollars and thousands of units. So we need to make this into thousands. So they should produce 85,000 DVDs. And it says what will the maximized profit be? That's our value for P, once again, in thousands of dollars. So we have $128,000, 8,500. Okay. Number 13, a local nursery sells a large number of ornamental trees every year. The owners have determined the cost per tree, C, for buying and caring for each tree it is sold, is this long number. In this function, C is the cost per tree in dollars and N is the number of trees in stock. So the question asks how many trees will minimize the cost per tree. So minimize, once again, vertex. Okay, if you have a maximum or a minimum, that's your vertex. So we're going to do the same thing. So in this case, N is negative B over 2A. So we would have negative times B. In this case, B is negative, so be really careful that you're bringing those signs down and keeping the negative that was originally in the formula. Over 2 times A, which is 0.001. Okay, let's pull up our calculator and plug that in. Alpha y equals for your fraction, negative times negative 0.3 over 2 times 0.001. Okay, and we get 150. So that means N equals 150. All right, so we're going to plug that 150 anywhere we see N in this function. Slide this back so we can see it. No, not full screen. Okay, so let's go ahead and type that in. Times 150 squared. Oh, not 33. And we get 27.5. So C equals 27.5. just jotting some notes. That's all I'm doing over here. So how many trees will minimize the cost per tree? Okay, well, it tells us C is the cost per tree in dollars. So C, this is our cost. And N is the number of trees. So this is our trees. So how many trees will minimize the cost per tree? And notice this one doesn't say anything about being thousands or anything like that. So we're just going to write it the way we got it. So 150 trees. What will the minimum cost per tree be? $27.50. Make sure you're writing your answers in the correct units. All right. So we are now on number 14. We're getting there. Still taking me a while to get through this study guide, so I hope you're bearing with me. The area of the rubber coating for a flat roof was 96 feet square. The rectangular frame the carpenter built for the flat roof has dimensions such that the length is 4 feet longer than the width. What are the dimensions of the frame? Okay, so let's first understand what the question is telling us. The length is 4 feet longer than the width. So that is our length formula right there. 4 feet longer is going to be plus, and the width is just going to be W. So our length formula is going to be W plus 4. Always put your variable first, okay? And then it tells us that the area was 96 feet squared. So remember that area is equal to length times width. So we'll have 96 equals our length, which was W plus 4 times width. I'm going to put the width first. If it doesn't mention the width or the length, whichever one it doesn't mention, you just plug in the variable for it. So whether it be L or whether it be W, whatever, they don't explain to you. So they did not explain the width to us in this problem. So we just put a W times our formula for length, which was W plus 4. Okay, the first thing we need to do is distribute this W out. So 96 equals W squared plus 4W. And then we want to subtract 96 so we can get this equal to 0. So we have W squared plus 4W minus 96 equals 0. Right, we're going to factor this out just like a normal trinomial. So negative 96 at the top, 4 at the bottom, 1W on each side. Okay, so what can we multiply to negative 96 and add to 4? Okay, pause the video for a minute if you need to figure those numbers out on your own. So it is 12 and negative 8. So we can't simplify these because this is just a 1W on the top, right? So we have W plus 12 times W minus 8. And we're going to set these equal to 0. Remember that our x values are the opposite of our factors, right? So W plus 12 equals 0 is just going to be W equals negative 12. Same thing here, W minus 8 equals 0 is going to be W equals positive 8. So you have a negative and you have a positive. So forget about your negative. We know that width cannot be negative, neither can length, right? So we need that positive number. So we figured out our width. Let's plug it into our formula and solve for length. So we would have 8 plus 4, which is going to give us 12. So we'll write our answer over here. Make sure you're writing your answers in the correct units. So our width is 8 feet. And our length is 12 feet. All right, number 15. A goalie kicks a soccer ball with an upward velocity of 65 feet per second, and her foot meets the ball 1 foot off the ground. Quadratic equation H equals negative 16t squared plus 65t plus 1 represents the height of the ball H in feet after t seconds. So H is our feet height and t is our time or seconds, right? So the question says, approximately how long is the ball in the air? Okay, so this is really asking you for your zeros, roots, whatever, same thing, x-intercept, okay? And then the next question says, what is the maximum height reached by the ball? So this is maximum. This is asking us for our vertex. And then the last question, how long does it take the ball to reach the maximum height? So how long, right? It's going to be our x value. If you think about looking at a graph, right? If we've got height and we've got t in seconds, then that h would represent our height, right? Think about this in terms of a graph. So we've got our height and we have our seconds. How many seconds is it at what height? So if it's asking us how long, that's asking us how many seconds. This is our x-axis. Okay, so this is asking us x, how long does it take to reach the maximum height? Once again, vertex. Right? So we can literally just plug this into the calculator and solve this. Alright, so let's plug this in. Remember, x is the same as any variable, okay? So your calculator can't plug in a t, but it can plug in an x, and it's the same thing. Let's graph it. Let's go to Zoom Standard. Alright, so we have a crazy graph on here. Let's do Zoom Fit. Alright, there it is. So, obviously, we're not going to have this negative, right? But we can still deal with the vertex and everything like that. Think about your graph. And think about if you kicked a soccer ball. You're not going to have this negative. So this space really doesn't exist. So we're only going to have the one x-intercept that's happening over here. Our vertex is good. It's in the positive zone. And then we're not going to go down either, right? So I really need to zoom this in so we can see it better. So this first quadrant is what we're looking at. So this zone right here is what we're looking at, nothing past it. All right, so first thing, approximately how long is the ball in the air? So we're looking for those x-intercepts. We're just looking at when we got from here to here. So second trace intercept. I'm trying to get as close as possible to that x-axis. Can't really tell where I'm at. So it gives us 4.077. We'll round that up. As long as you get a y value of 0, you know you found the correct one. So how long? Remember, answer this in the correct unit. So 4.08 seconds. Right, what is the maximum height reached by the ball? So we need to find our vertex. Second trace, we have a maximum. So let's go to the left of that vertex, make sure we're beyond it. And we have 2 and 67. But the question is, what is the maximum height, right? So our height was our y variable. So we don't care about this 2. We just want this time right here, how long it took us to get there, which is 67 seconds. Let's round this up to 0.02. So 67.02. I think I said that units wrong, but you guys get the idea. So how long does it take the ball to reach the maximum height? That was the other part that we just found. Time, height, 2.031. We're going to round that as well. 2.03 seconds. All right, let's go ahead and move on to number 16. The population of an apartment building is 4,000 people. Every month the population increases by 7%. What will the population be in 2 years? Okay, so we are looking at the population of an apartment building. It says every month the population increases by 7%. So we're looking at every month that it increases and what that actual population is. So remember that time is always our x variable, and we have time here, which is months. So our x variable is months, and our y variable is what we're trying to figure out, which is what is our population. All right, so 2 years. We haven't done these in a minute, so you might have to think back a little bit. But if we're noticing that our population increases monthly, we need to first convert this 2 years to months, which is 24 months. Okay, every month it increases by 7%. So we need to take this rate. Remember, if it's given to you as a percentage, that's your rate, and turn it into a multiplier. So first we need to convert 7% to a decimal, which is 0.07. And our population is increasing, so we're going to add this to 1. So our multiplier is 1.07. All right, remember our initial value is the same thing as our y-intercept. Okay, so 4,000 is what we're going to plug into our equation. So y equals our initial value of 4,000 times our multiplier of 1.07 to the power of x. Then it says to answer the question with the correct units. So we're just going to plug in 24 for x. Because we said 24, that's supposed to be an arrow. We said that 24 months is the equivalent of our 2 years, right? And we know that we're increasing monthly. So let's go back to our calculator, plug in our formula, 4,000 times 1.07 raised to the power of 24. And we get 20,289 people. Remember, we can't have decimal people, so we're not going to round that. So we have 20,289 people. All right, next page. All right, last page, guys. 17. You start a bank account with 5,000, but you are losing money. After the first year, you only have half as much money. If it continues to decrease at this rate, how much will still be in your account after 3 years? So let's define our variables first. So we're looking at the amount of money in the account, and then we're decreasing by years, right? So our variables, remember, time's always x, so it's years. And y is what are we trying to figure out, which is the amount of money in the account. All right, so let's go ahead and write our exponential equation. 5,000 is our initial value. And notice you have to look for those keywords. After the first year, you only have half. So remember when we filled out those notes with the word bank on there, keywords that meant certain things? This half right there is our multiplier. So 1/2. So we can write our equation, y equals our initial value. We started with $5,000 times 1/2 to the power of x. And the question says, how much will be in your account after 3 years? So we're going to plug in 3. Go back to your calculator over here. So we have 5,000 times 1/2 to the power of 3. And we have 625. So we will be left with $625 in 3 years. Starting with 5,000, they clearly need to find a new bank. Geez, sorry. I just realized everything is not necessarily writing the way I put it. All right, 18. You're ordering softballs for 2 softball leagues. The Pony League uses an 11-inch softball priced at $275. The Junior League uses a 12-inch softball priced at $325. The bill's smeared in the rain, but you know the total was 80 softballs for $245. How many of each size did you have? All right, so we're trying to figure out that this is a systems question, okay? We haven't done this in a minute, so you got to think back to remember how to do this. So we're going to start by defining our variables. Let's break down what the question says. We're looking at 11-inch softballs priced at $275, and we're looking at 12-inch softballs priced at $325. We're also trying to figure out how many of each we bought. We know we bought 80 total. How many of each did we get? And that's what that $245 and that 80 are going to tell us, right? So our variables will not be amount and cost, okay? We're looking at 11-inch softballs and 12-inch softballs. So those are our variables. All right, let's go ahead and write our systems of equations. So we know that we got X amount of softballs and Y amount of softballs. So we bought so many 11-inch and so many 12-inch, and totally we got 80. So that's just going to be X plus Y. We got 80. All right, so we also know we spent $245, and we know their cost, right? $275 and $325. So we're going to place those with the proper variables and set it equal to $245. So we would have 2.75 for the 11-inch, so that's X, 2.75X. And then 325 for the 12-inch, and that was Y, so 325Y. And we know our full amount was $245. All right, so now we can solve this first equation. Let's go ahead and solve it for Y. So we have X plus Y equals 80. And let's solve it for Y. So we're going to just subtract X. So we have Y equals negative X plus 80. So we know that Y equals negative X plus 80. So we can plug that in here. Okay, so 275X plus 325 times negative X plus 80 equals 245. So let's start by distributing this out first. So 2.75X, 325 times negative X is going to be negative 325X. 325 times 80 is going to be 260. All right, combine your like terms. So 275 and negative 325 is going to leave us with negative 0.50x plus 260 equals 245. And then we're going to subtract 260. So 245 minus 260 leaves us with negative 15. And then we're going to divide by negative 0.50. Right, so negative 15 divided by negative 0.50 gives us X equals 30. Okay, but we're not done yet. We need to find an answer for Y as well. So we can plug that 30 in here and solve. So Y equals negative. You have to keep that negative even though our value for X was not negative. Okay, so negative 30 plus 80 gives us positive 50. So let's answer the question. So we have X for 11-inch softballs, Y for 12-inch softballs. Just going to write a little note right here. So that means we have 30 11-inch softballs, and we have 50 12-inch softballs. All right, number 19. Given the graph, identify the transformations from the parent graph. Okay, remember our parent graph always starts at a vertex of 0, 0, so right in the dead center. So the question is, how do we get from that vertex to our new vertex? How do we get from here to here? Well, we had to go to the right, and we had to go down. So that means we have a horizontal shift right. Let's figure out how many we moved. 1, 2, 3. So horizontal shift right 3. And then we also have a vertical shift down. So 1, 2, 3, 4, I think. 1, 2, 3, 4. We'll call it 4. A vertical shift down 4. All right, number 20 and 21 say solve each of the following formulas for the specified variable. So we're just going to solve. V equals LWH, and we're solving for W. So we're just trying to get this W by itself. So W is being multiplied by L and H, which means we can just divide those away. So we can divide by LH, and then we're just left with W equals V over LH. Number 21. A squared plus B squared equals C squared, and we're solving for B. Okay, so what are we doing to B? Well, we're adding A squared, which means we need to subtract it to get rid of it. So we're left with b squared equals c squared minus a squared. But we want this b to be alone. We don't want this exponent, so we have to take the square root. And what you do to one side, you have to do to the other. But you can leave this just like that, so we'll leave it as b equals the square root of c squared minus a squared. Alright guys, we made it to the end. Last problem. Use any method to solve the following system of equations. So we have x equals 4y minus 8, and 3x minus 7y equals negative 4. Well, this one's easy enough. This is already set to the value of x. It equals x, meaning we can just plug it in right here for x. So we would have 3 times 4y minus 8 minus 7y equals negative 4. Okay, so let's distribute this out. We get 12y minus 24 minus 7y, keep that, equals negative 4. Alright, so we can combine 12y and negative 7y, leaving us with 5y minus 24 equals negative 4. We're going to add 24. So we have 5y equals 20. And then we divide by 5. 20 divided by 5 gives us 4. So y equals 4. Okay? And now that we know that y equals 4, we can plug that in to our original problem. So x equals 4 times 4 minus 8. So this is 4 times 4 is 16 minus 8. So x equals 8. But remember that your answer to any systems is an ordered pair. So our ordered pair would be 8, 4. Remember, it's x, y, so 8, 4. Alright guys, that is the end of the study guide review and walkthrough. I hope you guys understood and this helped you out a little bit. If not, please reach out to any of your teachers and ask any questions you may have, and good luck on your test.